All right, these are the 2.4 notes. If you have not watched the 7-minute video on the cheat sheet first, then you should go watch that. That way you kind of are a little bit up to speed. And then once you watch that and then start watching this, I think it'll all come together, hopefully. One thing I want to say before I start, make sure, just like in class, when I give you guys time to do some problems on your own, I'm going to do the same thing. Now, I'm not going to sit here and sit with a blank screen for 5 minutes while you do it, but please make sure you do your part. When I have some problems you do on your own, pause the video, do those problems on your own, and then I'm also going to do them, and then hit play, and then you can see me do them. If you want to fast forward a little bit to see the answers first, that way if you got them right, you don't have to watch me do them. You can do that for sure. But it will definitely be helpful for you guys if you take time to pause that and do some on your own to make sure you know how to do those. Okay, without further ado, let's get started with this. So if you watch the cheat sheet video, and I have that cheat sheet over here, this is where I'm going to use to get a lot of these. We talked about a parent function. Now, parent functions are the most basic form of functions. They are x squared, x to the third, square root of x, and absolute value of x. There are a bunch of other ones, but those are the 4 that we're going to be focusing on in this class. And if you don't understand why they are parent functions, I don't want to be this teacher, but honestly, just memorize those, because that's what we're going to be doing to move. We're starting with those, and then we're moving them up, down, left, right. Eventually, in the next lesson, 2.5, we're going to graph these, and so we'll be manipulating these graphs a little bit. But before that, we need to learn how you know when you go up, down, left, right, and how those all work, and get some practice with that. Then transformations, if you haven't figured it out, it's where you're manipulating any of your functions to make a different function. So again, you're moving it around, you're reflecting it, you're flipping it. Reflecting and flipping is kind of the same thing, but stretching it, compressing it, all that jazz. Oh, I did put this on here. Perfect. So I'm going to have you guys, I'm going to show you these first. Now, these are a little bit different. So these aren't with our parent functions. But when we talk about f of x, that just stands for any generic function. But these rules still apply. So if you have x plus 5, if it's inside your parentheses, just like inside the parentheses up here, that means you go left to right, and it seems like it's opposite. So x plus 5 inside, that means whatever this function is. Basically, you're moving the function f of x, and you're going to the left 5. X minus 6 outside your parentheses, that's this k. That is up and down, and that one makes sense. So minus 6 means down. So again, essentially you're taking your function f of x, and you're moving that down 6. Now, you don't have to put f of x every time. So this one, the negative sign is outside your parentheses. So that outside is this one. That's reflected across the x-axis. I really have trouble with the x and y axis because, again, they're really easy to flip-flop, so just make sure you're being careful. So this is reflected across x-axis. And this one inside parentheses is reflected across y-axis. Then if you have a number out front, if that number is bigger than 1, like this one, it is a stretch. It is a stretch by a factor, and this is what you'd call that every time, by a factor of 4. Now, honestly, if you put, I guess technically I should also add, this is a vertical stretch by a factor of 4. Now, I'm going to try to include the word vertical, and I'm trying to include the word factor of, because that's technically how it should be. But we're not going to be dealing with any horizontal stretches or compresses. And so if you just say stretch by 4, I can live with that. Again, I'm going to try to make it so it's more specific, but I can definitely survive with that stretch by 4. So go ahead and do these on, you probably see the answers, but go ahead, pause it, and do 6 through 11 on your own. Check your answers. Again, if you want to, there's not a lot to this for me to explain, but if you have the right answers, you can fast forward through this next minute. But pause this, do this on your own to make sure you know how to do these without just looking at the answers. So 6, it's outside the parentheses, so it's up 7. Number 7 is outside the parentheses, so it's down 8. Inside the parentheses, again, it looks like it's opposite. This is left. A lot of people miss that. A lot of people will put right 4, and that's not right. Again, I could explain why that is, but it does not help most students. Most students, it's just easier to remember. Inside the parentheses looks like it's opposite. -5 is to the right 5. See, I almost missed that. Outside of the parentheses is reflected across your, this should be the x-axis, I believe. Yes, sorry. Forgot to change that apparently. And again, that's a very easy thing to mistake. So make sure you're doing that. And then this one obviously is also wrong. That's reflected across the y-axis if it's inside your parentheses. So make sure you're looking at that distinction, because I definitely messed that up, and I actually messed that up a couple times, and I had to go back and change it, but I did not catch those. Oh, sorry, I didn't realize 12, 13 is on here as well. So do these on your own as well. You guys probably knew that, or at least now you do. So if you haven't done 12 and 13 on your own, pause it, do these on your own. So these have 2 steps to them, or this one does. The negative so actually, sorry, we'll get into multiple steps here. Technically, the negative makes it reflect, so it's reflected, and I forgot about that here. Reflect across the x-axis, because it's outside. And then it is a vertical stretch by a factor of 3. Remember, we don't care about that negative. If it's that 3 is what we're looking for, that means it's a vertical stretch by a factor of 3. If you struggled with that one, I apologize. I don't know why I put the negative. I'm sure I was just going too quickly. But you'll see more of that in the next one, or in the next section. And then the next one, this 1/2 is smaller than 1, so it's a vertical compression by a factor of 1/2. And that's the only difference. It's still vertical. The factor is still that number in front, 3 and 1/2. The only difference is if it's smaller than 1, it's a compression. If it's bigger than 1, it's a stretch. So the next one is when we have multiple steps. Now make sure the order does matter, and I will tell you this, on a lot of these, the order doesn't matter at all. But some of them they do. So I always try to make sure I do the correct order just in case. And it's kind of like the order of operations, but you're working on the inside out. So you're going to work inside your parentheses first. And then the next thing you do, if there's anything in front of your parentheses, you do that next. And then you move up and down very last. And so that's the order you go in. Now, again, some of these, it's not going to matter if you go in order or not. But I think it's almost easier just to do all of them in order rather than trying to figure out which ones you have to remember that and which ones you don't. So for this first one, we go left, left 3, then you go down 7. Now, this is the most common thing. You'll see this on your test a lot, where all it is left and right, and then up and down. There's nothing fancy to it. This one, you go to the left 2, and this negative is reflected across, and then it's negative outside, so it's the x-axis. If you're not sure if that negative is the x or the y, always go with x. You won't always be right, but the x reflection over the x-axis is more common. The next one, so there's nothing inside the square root, so the next thing is front, so that's reflect across, again, the x-axis, because it's outside, and then you go up 6. Then this one, you go inside first, so that's right 5. Then you go outside, that's another reflect across the x-axis. And then the last thing, 10, is up 10. So, again, the answers are here, but go ahead and do these on your own. If you want to use little abbreviations, you can. Just make sure everything is there. Don't just say across the x. Make sure you say it's a reflection across the x and stuff like that. So, inside out, this is to the right 5 and then down 6. And then this one, again, is to the left 4. That's the first thing since it's inside. And up front is reflected across the, again, this should be the x-axis. My apologies. And then up 7. That is why I need to watch the video instead of just scroll through, because apparently I make mistakes. I'm going to act like I did it on purpose. So the next thing is going backwards. So now, rather than giving you the function and then you saying what the transformations are, I'm going to tell you the transformation, and I want you to write the function. Now, don't make this harder than it is. Left 4 is inside parentheses, so it's x plus 4. Make sure you remember it's the opposite. Then up 10 is plus 10. Now, here's the thing. The hardest part is to make sure you still have to add a square root, because our parent function they gave to us, so that's what we're starting with. Same thing with this one, stretch by a factor of 3, which means that's outside, so 3 times x to the third. Don't forget your exponent. Reflected across the x-axis means that negative is out front. And again, they're giving us the absolute value. That's the parent function you're starting with. And reflected across the y-axis is negative x. So go ahead and do number 24 and 25 on your own. Again, obviously the answers are up here, but I mean, you can see the answers. You just have to make sure you can get to the answers. So again, this one, they give you the parent function. They give you 2/3 is what you're compressing it by. And again, it's a compression because it's smaller than 1. If all of a sudden I made that bigger than 1, like 6, then it wouldn't be a compression. It would be a stretch. But either way, the good news is it doesn't even matter, because whether it's 6 or 2/3 or whatever, you still put it in the function the same way. 2/3 times the square root of x. And then right 6 is negative 6. Down 8 is minus 8. So, next thing we have is when they have a specific point. And we'll do a little bit more of this later when we have a graph. But this is almost, it's the same idea. It's just a little bit different. So I included this new table. You will not get this table on the test, so make sure you remember this. But it kind of makes sense. If you go to the right, so we're dealing with an ordered pair. So if I take an ordered pair that's on a graph, if I go to the right, your x value changes. So you have an ordered pair, so let's say this is -3 up 2. If I go to the right, the 2 didn't change. It didn't go up or down, so the 2 is the same, the y value, but the 3 changes. We added something to that. And so it kind of makes sense if you think about it. If you're adding it, if you're going to the right, you add it to the x value. If you go to the left, you subtract it from the x value. Now this one does make sense. When you to the right is adding, to the left is subtraction. Same thing with up and down. Again, that's the y value. Your y value is the up and down value. That's your y-axis going up and down. So if you go up, you add whatever it is to the the y-axis. If you're going down, you subtract it. Now the good news, stretch or compress, it doesn't matter which one it is. Since it's vertical, whether it's a stretch or compression, you always multiply it by your y value. Doesn't make any difference whether it's a stretch or compression. You always multiply it by the y value. And then reflection, your x-axis, you make the y negative. Your y-axis, you make the x negative. And it almost seems like it's opposite. When it's the x-axis, you make the negative y. When it's the y-axis that you're reflecting over, you make the negative with your x value. So the biggest thing with this, the first step you're going to do is you're going to figure out what the heck the transformation is. Once you know that transformation, then you can use this table and you can figure out where your new point is. So the punchline is they give you this point, -4, 6. So what I always do is the first thing I do is I figure out what the transformation is. So this transformation, same as before, make sure the order does matter. So that is to the left 2, and then is down 3, just like we did before. So that is not anything new. But now we're going to do that to the point. So I go my -4, 6. If I go to the left 2, if you look at your chart, to the left, you're subtracting it from your x value. So the left 2, you're subtracting 2 from that. So you're subtracting 2 from this one. Then you're going down, down 6. So again, if you go down 6 is this one, so you're subtracting that from your y value. So now instead of -4, +6, you have -6, +0. -4 minus 2 is -6. +6 minus 6 is 0. So if you take that point, -4, 6, if you go left 2 down 6, you end up with -6, 0. That's where your ordered pair is. And if you want to check your work by using graph paper, you totally can. So 27, the x is inside, so it's reflect across the y-axis, since it's inside. And then the -1 is down 1. So again, we're starting with our point -4, -6. Sorry that I'm running out of room. I'm trying to squeeze it in here. So reflected across the y-axis means you make the x negative. So this x changes to its opposite, so that's positive 4, negative 6 is where we're at now. But we still have to go down 1. So some of them I do in 2 steps. This one I probably should have showed you in 2 steps, but it's pretty easy to do in 1. This one I think does help doing it in 2 steps. So reflect across the y-axis. Then we go down 1, just like we said, subtracted from our y. So we have 4, negative 7 for that one. This next one is a compression. So vert compress by 1/3. So remember, a compression, if you look up over here, it means we multiply the y value by whatever that compression is. So we multiply the y value by 1/3. So I know I'm kind of running out of room, and this is going to be a little bit messy. But we start off with negative 4, negative 6. I multiply the negative 6 by 1/3. I'm sorry, it's not negative 6, it's positive 6. Wondered, it seemed weird. So we end up getting negative 4, and then 6 times 1/3 is 2. Use your calculator if you need to. So negative 4, 2 is your answer for that one. Now again, if you're just going left to right, up and down, you can put them both in one step. But if you're doing anything else, reflections or stretches and compresses, I would do it more than one step. So this one, work your inside out. So this is to the right, 5. This negative is reflected across the x-axis. Plus 4 is up 4. And again, you want to do it in this order. Make sure you're being careful with that. So again, we're starting with negative 4, 6. To the right 5 is we add 5 to our x value. Again, you can check our chart. Negative 4 plus 5 is positive 1. So now we're at positive 1, 6 when we went right 5. Now reflected across the x-axis. The x-axis means we make the y value into our negative. And again, if you want to do a chart or a graph and actually look at this, you'll see why you're changing the y to a negative. But if I were you, I would just memorize that. So that's 1, negative 6. And then last but not least, we're going up 4, which means I add 4 to that y value now. And that ends up being 1, negative 2. Now that's a good example. If you did not go in that order, if you added 4 before you reflected it, then it's going to be a different point. So make sure you're sticking to that order. Go from the inside out. This one, same thing, left 2. This is a stretch by 3 and up 9. So we're starting with negative 4, 6. Left 2 means we subtract 2 from the x, so that's negative 6, 6. Stretch by 3 means we multiply our y by 3. So we have negative 6, 18. So we did this one, the last one we need to go up 9, so we add 9 to that. So we end up with negative 6. 18 plus 9 is 27, I think. So you end up getting negative 627. So go ahead and do the same thing with these. Again, this one, this negative 2 is actually 2 things. It's reflected across the x, and it is a vertical stretch. And those two doesn't matter the order. So we still start with our negative 4, 6. Reflection across the x-axis means our y value is negative. And then stretch by 2 means we multiply the y value by 2. So negative 4, negative 12. Which is what we had here. Perfect. And same thing over here. We have left 3. Sorry, right 3. I hope I didn't make that mistake earlier, but I maybe did. Right 3, again, common mistake, because it looks like it's opposite. Reflect across the x-axis again, and then down 8. Sorry, that's sloppy. I'm trying to fit it in. So again, we're starting with the same point. Right 3, we're adding 3, so that's negative 1, 6. Reflected across the x means we make that y value negative, negative 1, negative 6. And the last one, down 8, means we subtract 8 So this one ends up being, oh, I wonder if I did this one wrong. So apparently, sorry, this one should be -1, negative. I bet you I reflected it wrong. This one should have been -1, -14, it looks. So this answer is wrong. What I bet, I wonder what I did. I wonder if I moved it down before I reflected. You have to reflect it before you move it. So I bet you that's my mistake. I bet you I moved it first and then reflected. You do the right and left first, but then you have to go to the reflection and vertical stretches and compresses before you go up or down. You have to do it in that order from the inside out. So if you have any questions, make sure you let me know. You can email me. I'll try to get you as soon as I can. But remember, with this video, you can watch things over again. You can ask your friends. You can pause it. You can watch it later tonight. You can watch it before you take your test. Whatever you need to do, you can get that done.